Hi, I'm Raghav, continuing my series on cosmology. So far, we have discussed what we actually mean by the word Big Bang in the Big Bang model of cosmology, which is not any explosion in space but of space itself. Galaxies aren't flying through the space but are carried by its expansion. And the evidences behind my statements has direct or indirect contributions from the great personalities like Slipher, Leavitt, Lemaitre, Hubble, and Humason. Now today we start making models on our universe at large scales, actually very large scales, colossal scales, typically above 100 megaparsecs. But what is this megaparsec? So megaparsec is a unit of distance. We usually measure nearby distances in meters. Then we read the distances on the globe or say Earth scales. It is in kilometers. Then we read planetary distances, that is between the planets, in the astronomical unit or in short AU. Then we go beyond our solar system and read the stellar distances, that is till the nearby stars or between stars, in light years or parsecs. Then we measure the size of galaxies or say the galactic scale in few kiloparsecs. Then we read the intergalactic distances, that is between galaxies, in from like hundreds of kiloparsecs to a megaparsec. Then we go more beyond that and measure the distances between the galaxy clusters in hundreds of megaparsecs. So 100 of megaparsec is like 10 to the power 24 times a meter, or say 10 to the power 21 times a kilometer. So you must feel really, really negligibly small after knowing this. And at such grand, colossal cosmic scales, the universe is observed to follow two main fundamental properties, which we embed in one cosmological principle, which says that on the largest scales, universe is spatially homogeneous and isotropic. The two main words, homogeneous and isotropic. And this cosmological principle is nothing different than the Copernican principle. In 16th century, Copernicus told us that the Earth is not at the center of this universe. It is just like any other planet revolving around the sun. It does not carry any spatial place in this universe. The similar argument is also suggested by the cosmological principle. It also asserts that we are not at any spatial point in this universe. The large-scale behavior around us is similar to the large-scale behavior around any other point in this universe. Now remember that these properties, these fundamental properties, homogeneity and isotropy, only applies to the spatial dimensions of this universe. We will talk more about homogeneity and isotropy in the next videos. Now, if you find this video interesting and want to know more about this universe, cosmos, please follow my channel Aesthetics of Cosmos at YouTube or Instagram. Thank you.